Okay, so this is a problem where we have two masses connected by a rope, and they're both going around in a circle on a table, and you have two segments of rope. One of them connects to the first mass, and then another segment of rope connects to the second mass. The first one, obviously, we'll call it T1, and the second one T2. That's what we want to find. We want to find what T1 is equal to and what's T2 equal to. Therefore, we're going to start out with this mass here, the second one here. And the reason we're going to do that is because there's only one rope attached to it, you see? So if we start this problem off as we would any other centripetal problem, we go summation of the radial forces is equal to F net centripetal. And if we take a look at a free body diagram, now this is kind of like a bird's eye view. Let's take a look at it from a side perspective. So this one would be M2. There is basically one rope attached to it as it goes around and around. That means if we take a look at the free body diagram, what's touching it plus gravity, really we only have one force of tension, which is T2 here. And of course we also have gravity here, and we also have a normal force in this case, which these two forces cancel each other out. Fn, normal force, and m2g don't actually contribute to centripetal acceleration. They're actually canceled out because it's just sitting on the table going round and round. However, there is no friction, so therefore the only force contributing to circular motion is T2. Therefore, and it's pointing also towards the center. Okay, so if I was to draw it over here, it would look like this. There's T2. Therefore, what we can say here is we can say our positive T2 is equal to MAC, centripetal acceleration. And we all know that that is equal to mv squared over r. Now at this point, and by the way, what r is that? Just to be sure. And what m is that? That's m2. And that's R2, okay? Because R2 is out to the furthest one. The question actually tells us that the frequency is F. It doesn't really tell us what the frequency is, but we're supposed to find the answer in terms of it. So using the equation, the velocity is equal to 2 pi rf, we can now substitute that into here and get T2 is equal to m2 times 2 pi rf all squared divided by r2. And this is r2 as well. So this becomes 4 pi squared r2 squared f squared all over r2. And now we can cancel that, and our final answer, yeah. Oh, sorry, forgot the mass, right. Good point. There we go. Thank you. So if I wanted to make some more room here, and so our final answer should be 4 pi squared r2 f squared m2 all over nothing, actually. That's it. That's what T2 is equal to. Now, in order to solve for T1, let's do the whole thing again, but this time it's a little bit more complicated, because if we draw the free body diagram of the first mass, you see you've got the rope here and a rope here, and it's on the ground. Okay, so now if we draw the vectors, here you've got T1, and now you know that ropes can only pull, right? You've got T2 here, and of course, which is the center? Well, the center is over there. So now if we say summation of the radial forces is equal to F net centripetal, we've got positive T1 minus T2, and that's going to equal, and those are the only two forces. Obviously, yes, again, you do have, not two, that's one, M1G and Fn, but these guys cancel each other out, so we can forget about them again. So now, this is equal to M2AC, which is M2V squared over... Whoa, sorry, I'm making a mistake here. This is actually M1. We already did M2. Sorry, that's a 1, that's a 1, and that's a 1. Okay, so let's continue now. So we're solving for T1. So T1 is going to be equal to, again, let's do the substitution, M1 times 2 pi R1 F squared all over R1. But now, you see, we've got this term to take over to the other side, and now it becomes plus T2. Okay? And of course, the nice thing here is that we've already solved for T2, so, we can put it into there. So let's go 4 pi squared R1 squared F squared all over R1. We can cancel that and that. And then we can go plus 4 pi squared R squared S squared M2. And I forgot the mass again. There's the M1. So now, let's see if we can simplify this somewhat. Let's go 4 pi squared R1 F squared M1 plus 4 pi squared R2 F squared M2. Now, what common terms do you see here? Yeah, there's a common term of 4 pi squared F squared, right? And now we can go like this and like that, and that's our final answer for T1. So we're done. That's our final answer for T1, and our final answer for T2 was right there. Hope you enjoyed that problem.